Here's a typical exam or test question. We're going to construct two truth tables. The first one will be for this statement here, that P implies Q, or you might like to think of it, if P is true, then Q is true. This is a conditional statement. So we'll construct a truth table for that statement. Then we'll construct a truth table for the right-hand side, for this compound statement, that not P or Q, or you might like to think of it as not P is true or Q is true. Now, if the results of the two truth tables are the same in all cases, then we're going to say that the two are logically equivalent. So let's start with the truth table for the left-hand side. And to do these truth tables, we've got P and Q here. In some cases you may even have P, Q and R, but in this case we've just got P and Q, and so we need to look at every case. So we put P and Q across the first row, and then we put all the cases. So we're going to have P is true, Q is true. That's the first row. Second row will be P is true, Q is false, and then we'll fill out the table with all the cases. Now, sometimes it helps to try to use a real life sort of example to help you understand, particularly in the early stages when you're new to these sort of problems. So let's imagine that P is the statement that the object is a ribbon, and Q is the statement that the object is red. And we're examining P implies Q, which is the statement that a ribbon implies red, or if you like, if an object is a ribbon, then it is red. So we're now going to look through the four cases, and if what we see in front of us disproves ribbon implies red, or P implies Q, well then we're going to put false, but otherwise we're going to put true. So we're walking along and we see, first up, a red ribbon. So P is true and Q is true. So this is the first row of our truth table. And so does this occurrence, this red ribbon, does this support or disprove the statement that, if you like, all ribbons are red? Well, it does. It does prove it, and so we'll put true there. Now the next case, we come across a blue ribbon. So P is true and Q is false. And in this case, this actually helps us disprove the statement that all ribbons are red. So here we'll put false. Now the next two cases are in some ways the most difficult. We now come across a red leaf. So P, which remember was this object is a ribbon, well that's false. Q, this object is red, well that's true. So we're looking at the case false and true. And in this case, I think what we can certainly say is, when it comes to does P imply Q, does ribbon imply red? Well, we certainly haven't disproven it. So we can't put a false there, and really all we can put here is true or false with all of these statements. They can only ever be true or false. And so we're going to have to put a true here. So this is a little bit hard to come to terms with. You may need to do a little bit of thinking and work on that. This is a true statement. And similarly, let's say we come across a green leaf. So this is a leaf. So it's not a ribbon. So P is false and it's not red. So Q is false. And once again, this does not disprove the statement that ribbon implies red. And so we would put true there. So we've finished our first truth table. Now let's go on to the second truth table, which in some ways is easier. Once again, we start with P and Q and we fill it up with the four cases. Now we put not P. So For the first case, we have P is true, so not P is false. Second case, P is true, so not P is false. And then for the last two rows, or last two cases, we have P is false, and in that case, not P must be true. And now we ask the question, is not P true or Q true? In other words, is one or more of Q and not P true? So in the first case, well, we've got Q is true, so clearly not P or Q is true as well. Second case, they're both false, so not P or Q will be false. The third case, they're both true, so not P or Q will be true. And the fourth case, we certainly got not P being true, and so not P or Q will also be true. And now we can see the result of the two truth tables is exactly the same. You can see here, true, false, true, true, and true, false, true, true. So we could conclude the solution by just saying the results of the two truth tables are identical, and so P implies Q is logically equivalent to not P or Q. That's it for Truth Tables Made Easy. I hope you found it useful.